simple understanding, a scalar is nothing but a number. You told vector should have magnitude as well as direction. How do I represent the direction here? My good students, draw an arrow. Will my mass become 25 kgs? No, my mass is the same. A unit vector is always used to indicate directions. Hello students. Thought for the day. We have all grown up hearing that learn from your own mistakes. But I strongly believe there are too many mistakes outside from which we can learn. This is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Dear students, previously we have studied the nature of a moving body in a straight line, one-dimensional motion. Here, a new chapter, a new session which describes the motion of a body in a plane. A very significant chapter. The weightage of the chapter is nearly 8 to 10 marks in your exam. It also forms the fundamental for vector algebra in your 12th maths. And for any entrance exam, this is a decider. So please do follow this session with utmost intensity and responsibility. So we discuss the concepts of motion in a plane. Dear students, the first definition that I take up in this chapter is something which we have already realized earlier. The meaning of a physical quantity. ಏನು ಹೇಳಿದ್ವಿ ಮಕ್ಕಳೇ? Physical quantity ಅಂದ್ರೆ? Very good. We told it is a quantity that can be measured directly or indirectly. Any quantity which we can measure directly or indirectly. Indirect measurement and ನೆನಪಿಸ್ಕೊಳ್ಳಿ. Mass of atoms and molecules, atomic mass unit. Large distance between the earth and planets. They are all indirect measurements, and therefore we told all measurable quantities are physical quantities. And I also made it very clear, there is nothing called non-measurable which becomes philosophic. Now students, understanding the classification of a physical quantity, basically we say we learn two terms or two types of physical quantities. One, what is called as a scalar. The other one is what is called as a vector. Very basic understanding in physics. You can say this is the basement of physics, fundamentals of physics. Understanding what is scalar and what is a vector. We will now try to understand what is a scalar. By definition, there is no hyperbolic physics in this. Scalars are numbers. By simple understanding, a scalar is nothing but a number. But how is it related to a physical quantity? My dear students, a scalar is a physical quantity which is described only magnitude and no direction. Beautiful agide alva? When we talk about a scalar, it is a physical quantity where we say having only magnitude and no direction. It is independent of direction. Means what? What do I understand by that? See, for example, if you say mass, I say my mass is 50 kg. So 50 is the magnitude, it's a number. Kg is the unit. Nenpuskoli, very first class. So my mass is 50 kg. Where I say 50 is the magnitude, number, and kg is the unit. If I go to the next classroom, will my mass become 100 kgs? Will my mass become 25 kgs? No, my mass is the same. I go to the next classroom, I go to the physics lab, I go to my home, anywhere I go, irrespective of the direction, my mass is remaining 50 kgs, which means my mass is described only through a number which is 50 and irrespective of any direction. So mass becomes a scalar quantity. The length of this pen inside this classroom, 10 centimeters. I go to the chemistry lab, 20 centimeters. I take it home, 50 centimeters. Then you say, boss, something is specially unique. Wherever I go, the length of this pen should remain the same. If I say 10 centimeter, in all directions, it is 10 centimeters. So I only require that 10 to describe the length of this pen. Time, same. So such quantities where I require magnitude but no direction to describe, they are called as scalar quantities. And remember, Scalars are always numbers. Vector. Now, vector quantities are those physical quantities which has both magnitude and direction. So, to describe a vector quantity, I require both magnitude and direction. For example, force acting on a ball is 10 newtons. I kick the football with a force 10 newton magnitude bantu in a certain direction. Direction also comes into play here. So force becomes a vector. Velocity. A car is moving with a velocity of 5 meters per second due east. 5 is the magnitude, east is the direction. So any such quantities like momentum, velocity, acceleration, force, where I need both magnitude as well as direction to describe, they are called as vectors. So scalars, they require only magnitude but no direction for their description, whereas vector requires both magnitude and direction to describe them. Now, let us understand how do we represent a vector. Now, I consider a point A, some point A, arbitrary point in a plane, and using this, I draw a line segment AB. ಏನು consider ಮಾಡಿದ್ದೆ? ಒಂದು point, what I call as A. Using this point, I have drawn a line segment AB. And I say the length of this line is 5 centimeter. So initial point is A, ending point is B. A is the initial point, B is the terminal point, and the length of the line is 5 centimeters. Now, this 5 centimeter is giving me the magnitude, the length of the line AB gives me the magnitude. Magnitude ಏನು ಸಿಕ್ತು, direction ಬೇಕಲ್ವಾ? How do I represent the direction here? My good students, draw an arrow. Now this becomes directed line segment. Direction from where to where? A to B. See, the arrow is from A to B. It is a directed line segment. A line with an arrow. Therefore, any vector is represented by a directed line segment where the arrow at the end gives me the direction and The magnitude is given by the length of the line. Therefore, we write vector AB is equal to 5. So, always a vector quantity is represented by writing a directed line segment over its head. For example, force. Force is a vector. F vector. I write F and a directed line segment. The moment I write this directed line segment, it means it is a vector. Momentum represented by P, directed line segment, vector, acceleration, directed line segment. So please to understand here afterwards, whenever you indicate a vector, you have to write a directed line segment. So any vector is represented by a directed line segment. Length of the line gives the magnitude, arrow at the end direction. So it is magnitude plus direction, which is called as a vector. Now, if you go through this table, I've given you a list of physical quantities. Refer to this session. I want you all to analyze which are the vector quantities here and which are the scalar quantities. Continuing further, this is very important. Something called types of vectors. Now you understood what is a vector. You told vectors should have magnitude as well as direction. Now we will go through the classification, the types of vectors, where the first vector is zero vector, or what is called a null vector. Now let us go through the definition of a zero vector. A vector which has zero magnitude is called a zero vector or a null vector. Very interesting. Any vector which has zero magnitude, no magnitude at all, is called a zero vector or a null vector. Now the question is, which physical quantity can I think of which has zero magnitude? Will that quantity practically exist? Yes, it exists. Therefore, we have a zero vector. The example is a point that is placed in a plane. Point. The smallest object in a plane. Point. What is this magnitude? We always say point has zero magnitude. So classical example for zero vector is a point that is placed in a plane. Its magnitude is zero. If you extend this point, what you get? It is a straight line. Straight line will have some specific magnitude. So the classical example for a zero vector is a point, and you can see for a point You cannot distinguish between the starting point and the initial point. Alva? So, the example for a zero vector is a point which is placed in a plane. So, my dear students, what is a zero vector? Simple, sir. Having zero magnitude, which is placed in any arbitrary direction in a plane. Classical example, an object without extension, which has to be a point in a plane. The next one is what we call unit vector. This is very important. A vector whose magnitude is 1 is called as a unit vector. Unity andre 1 alva. So it is a vector whose magnitude turns out to be 1. Zero vector, magnitude is 0. Unit vector, magnitude is 1. And it has a very unique representation. How do I identify a unit vector? A unit vector has a hat or a cap on its head. Nodi, idana directed line segmental indicate madala. Unit vector is written as a cap and it is called unit vector A. Speciality of a unit vector represented by caps or hats. So A cap, which is equal to vector A divided by magnitude of vector A. And this is how we represent a unit vector. Value of vector A divided by magnitude of vector A. And what is the speciality of unit vector? The speciality of unit vector is it is used to indicate directions. Always remember, a unit vector is always used to indicate directions. Equal vectors, as the picture shows and the conditions read, I have two line segments, AB of 4 centimeters, CD of 4 centimeters, which means both of them have the same magnitude. Look at the arrow directions. Good. Both the vectors are in the same direction. Such vectors are called equal vectors. Equal. Both of them should have the same length, same magnitude, and they should act in the same direction. Then they are called equal vectors. Negative of a vector. Again, look at the diagram. Length of AB is 4 centimeters. Length of CD is also 4 centimeters, which means they have the same magnitude. Both the vectors are equal in magnitude. But what about direction? They are acting opposite to each other. The arrows clearly specify they are opposite. Such vectors are called negative of a vector, and therefore we write vector A is minus vector B. So students, in this class we have introduced ourselves to scalars and vectors, and we have learned the different classification of vectors. Coming up in the next session, we will study the algebra of vectors. Until then, have a thought on this session. Have a great time. Thank you.